the beautiful South Studios of Way Happy, we are doing P6 complex numbers, and you might remember complex numbers because they have the imaginary part, the part that we told you never really existed. And you have to remember that I is defined as the square root of -1. That's what you have to know. Every time you see an I, you have to know it's that. And more importantly, I would almost say is that I squared. Then if we square both sides, then I squared is -1. And why is that so crucial? Because the fact is that you will always be able to substitute in a -1 whenever you see an I squared. And you want to be clever about it, because if you have I to the fourth, then that's just I squared times I squared. And you're like, ooh, that's a -1 times a -1, which is a 1. And so super important, and make sure you got that down. Now, what do you need to know? You need to know what a complex number is. A complex number is of the form a plus bi. And a and b are real numbers. The I is just tacked on there so you know. And what you might say is every number in the world is actually complex. Your age is a complex number because I'm 44. So I could write it as 44 plus 0i. Right? There's no imaginary parts. So all real numbers can be written as complex numbers. So they make up the set of all numbers ever. They can be added. You added like parts with like parts. So if you have 2 plus 3i and you add that to 5 minus 2i, then all you would do, make sure you notice that this is addition. You would just add them. So real parts would be 7 and imaginary parts would be I, or 1i. And that would be your answer. All right, but multiplying can be tricky. So let's talk about multiplying, and dividing also can be tricky. So multiplying, it's just foiling. So if you're somebody who likes the box method, which is fine with me, you would do your box method. You'd have 3, you'd have 2i, you'd have 4, and you'd have -i. This is also the same thing as foiling for those people who foil. This is just 12. This is 8i, this is -3i, and then here's the big one, -2i squared. Why is that big? Because of the I squared there. And what do you get when you have this? You have a 12 plus a 5i if you combine those two. And here you have really a -2i squared, which is a +2. So that looks to me like 14 plus 5i. There's the real part, the imaginary part. And that is how you foil. Remember to always take care of those I squareds and you will never be in trouble. There is something called the complex conjugate, or just the conjugate if you want. Like, say you have an imaginary number and you want to get rid of it, or a complex number, so 1 plus 3i, and for some reason you need to move it out of the denominator. Maybe sometimes in math you'll have to rationalize the numerator. So it really doesn't matter where it is. But if you want to clean it up so that there's no imaginary numbers somewhere, like in this case the denominator, you multiply by what's called the conjugate, where you change the sign on the b. So this would be 1 minus 3i to the top and bottom, of course, because that's got to be multiplying by 1 so it doesn't change the fraction. But look what happens. You'll get 1 minus 3i on the top, but look at the bottom as I foil this out. Now, I did box before, so I'll foil this time. You get 1, you get minus 3i, then you get right behind it plus 3i, and then right behind that you get minus 9i squared. But why is that so cool is your denominator now has no i's in it. So 1 minus 3i, but look at the denominator. 3 i's canceled each other out. And I squared became -1, so that's really a +9. So this is all over 10. And you have just rationalized the denominator. You can also rationalize numerators. If somebody saw this problem and they say, ooh, I don't want the I in the numerator, then I'd multiply by 1 plus 3i in top and bottom, and that would clean up the numerator so it didn't have any imaginary parts in it. So when you need to move imaginary parts, you want to use complex conjugates. All right, give you a question and I'll be right back. Nice work there. All right, now on to quadratic equations. And you've seen the quadratic formula. And just want to let you know that there's a little part of the quadratic formula that's pretty important. It's the part under the square root. And why is it important? Because if you think of your quadratic formula, opposite of b plus or minus the square root of really what's called the discriminant, b squared minus 4ac, all over 2a. That discriminant is important because it's what's under the radical. So there's a chance that if you do that math and you get a negative number, you're going to have a negative under a radical, and imaginary numbers are going to show up. So that's why the discriminant is important. So people just like to say, I think it's almost like if you thought about it, you'd say, hey, that makes sense. if that stuff under the radical, b squared minus 4ac, is greater than 0, meaning it's positive, that means you can take the square root of a positive number. You're going to get some gross answer, but you're going to be able to do it. Then it says if it's 0, then you're going to take the square root of 0. You're going to have plus or minus 0. That's not going to do anything, so really the answer is just negative b over 2a. And in this last case, if your b squared minus 4ac is smaller than 0, so what you're putting under the radical is negative, you now are going to have imaginary solutions, and that's what we're talking about here. There is going to be imaginary solutions. So let's see one that I got, right? First thing I would try to do is factors. Anything multiplied to 2 that add up to 1? No. So then I would go, obviously, to quadratic formula. But a step in the quadratic formula that's always helpful is to do b squared minus 4ac. That's called the discriminant. So for us, that's 1 squared minus 4 times 1 times 2. So that would be 1 minus 8 or negative 7. That's the discriminant. Right now I know I'm going to have two imaginary answers. And then you can go solve them. X is equal to the opposite of b, what is b, negative 1, plus or minus the square root of the discriminant, all over 2a. And there you go. So I got negative 1 plus or minus I root 7 all over 2. And to clean that up a little bit, I'll have negative a half plus or minus I root 7 all over 2. And that's how the discriminant gives you a little bit of help on the quadratic formula. Gives you an idea of what answers to expect. When I knew I got the negative 7, I was like, oh, this problem's going to have an I in it, right? And then if I was multiple choice, if there was 3 answers that didn't have I's in them, I'm crossing them all out and I know the answer. So that's what's super nice about knowing the discriminant. You got to do it anyway. So why not check what kind of solutions you're going to have? That's it. Have a great day. Stay happy.